Scientists are stunned. Impossible black hole collision detected. Scientists have detected the most massive merger of black holes ever. This titanic collision, heard in ripples in space-time called gravitational waves, involves black holes so massive that it could challenge current models of the universe. The merger was detected by the Gravitational Wave Detector Network, LIGO Virgo Cagra. On November 23, 2023, during the fourth observing run of these three sensitive laser interferometers located in the US, Italy, and Japan, the merger event that set space-time ringing with this gravitational wave signal, designated GW231123, involved progenitor black holes with masses of 100 and 140 times that of the Sun. These two were so massive that when they merged, they created a daughter black hole 225 times the mass of our Sun, with the missing mass converted to energy, propelling gravitational waves that rippled out from the violent event. You may like an artist and number 039. It's illustration of two black holes spiraling together, creating gravitational waves in the process. Black hole dance illuminates hidden math of the universe. There is a wave of pinkish gas trailing behind each of them. A purple-hued image showing two black circles circling around one another in the center. What can ripples in space-time reveal about black holes? Quite a bit. It turns out this was detected in 2021 as the signal. GW190521 LVK collaboration, and Cardiff University researcher Mark Hannum said in a statement. Black holes this massive are forbidden through standard stellar evolution models. The signal seems to indicate that prior to the merger, at least one of the progenitor black holes was spinning rapidly. Perhaps as rapidly as the laws of physics allow, in fact. A giant radio galaxy is seen by the Hubble Space Telescope and the Carl G. Jansky Very Large Array Radio Telescope. Astronomers discover 15 new giant radio galaxies, the largest single objects in the universe. Click here for more space.com/videos. Prior to GW231123. The most massive black hole created in a merger and detected in gravitational waves had a mass of 140 times that of the Sun. This is the most massive black hole binary we've observed through gravitational waves. It presents a real challenge to our understanding of black hole formation. One possibility is that the two black holes in this binary formed through earlier mergers of smaller black holes. The monstrous masses of these black holes are not the only things that make GW231123 so interesting. LVK member Charlie Hoy of the University of Portsmouth said, that makes the signal difficult to model and interpret. It's an excellent case study for pushing forward the development of our theoretical tools. In 2015, its twin detectors based in Livingston, Louisiana, and Hanford, Washington, made the first ever detection of gravitational waves. Get the Space.com newsletter. Breaking space news, the latest updates on rocket launches, skywatching events, and more. This resultant collaboration has now detected over 300 black hole mergers. Your email address, as impressive as that is, the high mass and rapid spin of the black holes that clash to create GW231123 have pushed the limits of gravitational wave detection technology and perhaps the bounds of current theoretical models, too. Contact me with news and offers from other future brands. It's a powerful example of how much we can learn from gravitational wave astronomy and how much more there is to uncover. Receive email from us on behalf of our trusted partners or sponsors in March 2014. Astronomers announced the first detection of long-sought gravitational waves, though some critics now say the finding could be merely dust. By submitting your information, you agree to the terms and conditions and privacy policy and are aged 16 or over. Despite the most likely explanation remaining, a black hole merger, more complex scenarios could be the key to deciphering its unexpected features. The black holes appear to be spinning very rapidly, near the limit allowed by Einstein's theory of general relativity. Another record broken for LIGO and partners, the Laser Interferometer Gravitational Wave Observatory, is no stranger to making history and breaking records. This detection came exactly a century after Einstein had first predicted the existence of gravitational waves in his 1915 theory of gravity. General relativity. The signal, which would become known as GW150914, was the result of the merger of black holes that created a daughter black hole with a mass around 62 times that of the Sun. This artist's illustration depicts the creation of gravitational waves from two orbiting black holes as ripples in spacetime. This artist's illustration depicts the creation of gravitational waves from two orbiting black holes as ripples in spacetime. Since 2015, LIGO has been joined by the gravitational wave detectors Virgo and the Kamioka gravitational wave detector. Over 200 of these detections have occurred in the fourth operating run of these instruments. This event pushes our instrumentation and data analysis capabilities to the edge of what's currently possible. LVK member and California Institute of Technology researcher Sophie Bini said, "Related stories. This is the holy grail of theoretical physics. Is the key to quantum gravity hiding in this new way to make black holes? Tiny primordial black holes created in the Big Bang may have rapidly grown to supermassive sizes. A primordial black hole may zoom through our solar system every decade, fully unlocking the secrets of this signal and others that LVK detected up until the end of its fourth operating run. In January 2024 will require the refinement of analysis and interpretation methods. It will take years for the community to fully unravel this intricate signal pattern and all its implications." LVK team member Gregorio Carullo of the University of Birmingham said, "Exciting times ahead." GW231123 was presented at the 24th International Conference on General Relativity and Gravitation and the 16th Eduardo Amaldi Conference on Gravitational Waves in Glasgow, Scotland on Monday.